Welcome to the MTD CNC Technical Corner. Today I have the privilege to be joined by Ben Miller from SolidCam UK, and we will be discussing new strategies and solutions for fifth axis full simultaneous machines. Welcome, Ben.
Thanks very much, Gio. Thanks for having us.
It's an absolute pleasure, Ben, and I'm really looking forward to learn more about the products that you offer for fifth axis simultaneous machines. So firstly, Ben, can you give me a brief overview about the products that you offer for a fifth axis simultaneous machine, and just give us a little bit of an insight into why you should be a preferred supplier to many machinists?
Yeah, so we offer full support for five-axis machines, whether that be indexial or simultaneous. We can produce post-processors for any machine with 5 axes or more axes. We can do positional work with more axes and that, simultaneous with 5 axes. And we've got different strategies for different applications and different tooling within SolidCam as well.
Do you still use eye machining on fifth axis machines also?
Yeah, so eye machining is a high-speed roughing cycle. It does have a wizard in there as well for calculating speeds and feeds and depth of cut for you. We do use that on 5-axis machines. We use it indexially, so we can index to a plane, rough a certain area out, and so on.
Now, conical barrel cutters, they've been around for many years. However, they're being used more and more now for some of the planes that are being produced on fifth axis simultaneous machines. And some of the cycle time reductions are breathtaking, really, and just don't seem real. What kind of strategies do you have for conical barrel cutting, and what kind of general savings are possible?
Yeah, so with the conical barrel, traditionally you would have a part, maybe have a deep pocket, really tight corners in there. Traditionally you would use a ball nose cutter for this type of work. You'd be looking at a sort of step over of maybe 0.1 as you go down the wall to maintain the surface finish, giving you a small cusp. With the conical barrel, bringing that tool into the mix instead of the ball nose, you may have a sort of 95 radius on the side of the cutter, so you can increase the step over whilst maintaining the same surface finish and cusp height, really. So you may increase the step over to 0.7 up to a millimeter step down with a radius that large. So going from a 0.1 step down to a 1 mil step down will give you a 90% cycle time saving just by that alone.
I mean, that is really fascinating, really. Now, in regards to the fifth axis machine applications, more and more people now are presenting more than just one component to the spindle with some clever work holding solutions. What kind of mirror kind of software are you using so you can produce more components on the machine tool?
Yeah, so within SolidCam we have plenty of translation sort of operations where we can translate the cycles. We could produce the same handed component by just translating the operations, and we've also got mirror machining as well, so we can produce left and right handed parts just with a couple of clicks within the software.
So it's safe to say that you can reduce cycle times on fifth axis machining, but what about the simplification of programming?
Yeah, so we can simplify the operation list inside SolidCam. We can also reorder the operations to make them more efficient, especially when you do sort of the mirror machining. So we could, once we've got one tool out, we could use it on both components at the same time rather than having extra tool changes in there. You've also got the consistency of producing programs using the customized processors that we would create for each and every customer and each and every machine.
What do you mean about the consistency? Can you go in a little bit more detail about that? Explain what you mean, please, Ben.
Yeah, so we can add functions into a post processor that will give the user extra functionality within the software. We can also make sure their G code is minimized and as efficient as it can be. for that machine tool as well. We can make it easy to read for the operator rather than just dumping out the code that will work. We can make sure the operator can read that code as well. So if things do need changing at the machine tool, they can be quickly and easily adjusted and adapted really there and then.
Thank you, Ben. Now, Ben, what other machine tool configurations do you support before we go?
Yeah, so we support all the machine tool configurations. With regards milling, we would be looking at 3-axis, 4-axis, 5-axis machines. We support the advanced mill turns as well, so we also support turning. So right from basic 2-axis turning up to the advanced mill turns, the Swiss types, and unlimited number of axes and channels regarding the advanced mill turns and Swiss types.
Ben, thank you very much for your time.
No problem, thanks very much.